Hello, and thanks for stopping by to check out this episode of Vintage Audio Review. In this episode, I'm going to talk about this Kenwood KA-7100 Integrated Amplifier. In my last video, I had mentioned I was at a dinner with a couple friends, and one of them had a broken Kenwood receiver, which was the subject of the last video. The other friend had a friend who owns this, and my name came up as somebody who could possibly fix it. I'll get into what was wrong with it shortly, but I wanted to talk a little bit about this unit. So I did a little bit of research on this unit, and it was made between 1977 and 1979 and sold for $315, which would be the equivalent of about $1,400 in today's money, for what that's worth. It was rated at 60 watts per channel from 20 hertz to 20 kilohertz, with both channels driven into 8 ohms at a THD of not more than 0.02%. While there are several videos on YouTube about the KA-7100, there's none that really go into how it performs today. So before we get into the measurements, I would like to show some of the features both on the front panel and the back panel of the KA-7100. So here is the front of the KA-7100 Integrated Amplifier, and it is just a silver-faced beauty is all I can say about it. It's just gorgeous. So here we have our power switch. Here is a headphone jack. Here's your speaker switch, and it can select between 2 sets of speakers. And so you have A, B, A plus B, or off. The speaker switch is independent of the headphone output jack. Here we have our bass and treble controls. Now we have a tone control here which has a defeat and an on position. When it's on the on position, you can use the bass and treble controls. If you put it on the defeat position, it bypasses the bass and treble controls, giving you a more direct and pure path to the power amp stage. Here's your balance control. It has a 20 dB attenuator. We've also got a high filter and a subsonic filter. We'll go to the volume control in a minute. Here we have a loudness switch which has 2 settings for different amounts of loudness, and this is the first integrated amplifier or preamp I've seen that has 2 different loudness positions. You have a mode selector here which is for stereo, mono, or it can reverse your left and right speakers. And here we have your input selector. It's a little light, but it has all your basics, your auxiliary tuner, and a moving magnet phono input. Here is your tape selector for 2 tape monitor circuits. So this is the volume control, and it is a little bit different than other volume controls in that it uses resistors around a switch, and that allows for more precise increments and repeatability in your volume control action. It also is detented, so you can feel every little step along the way. It would be nice if it had a backlight around it, but that's fine. It still looks really good and it works great. So that is the front of the KR-7100. We're going to move around to the back now. Okay, so this obviously is the rear of the KA-7100. One thing I will point out right away are these 2 rubber feet things which act as a stand. If you wanted to set the unit up on these, you could do that without damaging anything. I'm not sure necessarily why you would want that feature, but that's its purpose in life. Here you have your ground lug for your phono. Your phono's here, auxiliary here, tuner's here. You have your 2 tape monitor circuits, with one of them having a DIN jack if your tape deck is so equipped. These are your speaker output jacks, and they are not banana friendly, so you have to stick your wires in there. That's kind of a bummer. We also have a unswitched outlet and 2 switched outlets over here. One other feature that I wish this amplifier had, other than a lighted volume knob bezel, would be a pre-out main in jack, so you could separate the preamp and power amp if you so desired. But other than that, it's very simple and it works rather well. So this is the inside of the KA-7100, and there's a few things I'd like to point out. One of them is that the input selector and then the tape monitor selector here and here are actually switched. The actual electrical switch is down here and here. And what that does is it minimizes the distance that the signal travels when it first comes in, whichever input is selected. It travels in on this board, and then the output, it looks like it comes down here and eventually comes down to the preamp tone control board here. One of the nice things about the KA-7100 is that each channel has its own power supply. Even though there is one single transformer, there are two sets of rectification going on here and here, and then you have the two sets of power supply for your plus B rails. It is a class AB design, so you have PNP and NPN transistors here. So that is the inside of the KA-7100. So the problem that the KA-7100 had when it came to me was that one channel you could not hear at all until you had the volume cranked up about 2/3 of the way. So I believe it was the left channel you could barely hear, the right channel was fine. You'd go to crank the volume control to about 2/3 of the max volume, and all of a sudden it would get real loud because the other channel came on. We played with it for a little bit, and then the other channel started doing the same thing. One channel's good, the other channel you can barely hear, you crank up the volume control, and all of a sudden it pops in. It turns out the culprit was a dirty or noisy tone switch, the one that says tone, defeat, or on. And apparently it just had built up some corrosion in it, I will say, or oxidation most likely, and some treatment with deoxit F5 and D5 got it working fine. And hopefully So our first piece of data is the THD SNR plot with the integrated amp running at 5 watts into 8 ohms and set for 29 dB of gain. Both the SNR and THD look really good, and the THD plus noise looks pretty good as well. So we're off to a good start. Here we have the frequency response under the same conditions as the previous data, and this is of course for the auxiliary input. And we can see that we have a flatness of about 0.7 dB worst case. So that is pretty good. Now note that this is for the tone defeated, so we're not going through any of the tone controls. So here we have the frequency response under the same exact conditions as the previous frequency response, except the tone switch is on, so that the signal is going through both the bass and treble controls, which are set for 0 or flat. So we can see there is definitely a difference, and this is the way this particular KA-7100 is going to operate now due to the bypassing of the tone switch. And speaking of tone controls, here are the effects of moving either the bass or treble control to their minimum or maximum positions, which would be plus or minus 7.5 dB. And the spec for them at 100 Hertz, at least the bass control, it is plus or minus 7.5 dB. And for the treble control, it is plus or minus 7.5 dB. And if you look at the reference line, which would be the flat response, you can see that we're pretty much meeting that spec requirement. Now this nice looking frequency response is for the auxiliary input to the tape monitor 1 output. And I'd say it's flat to within about 1/4 of a dB. There is a spec for this, however it's measured between 10 Hertz and 100 kilohertz, and it's spec'd at plus 0 dB to minus 1.8 dB. So maybe if I were to extend my sweep out to 100 kilohertz, we would get down to 1.8 dB. But I'm pretty happy with this at 20 kilohertz, only being down 1/4 of a dB. So this is the frequency response of the phono input to the tape monitor output. And the spec is plus or minus 0.2 dB across the frequency band. What I'm measuring is about 0.3 of a dB flatness for the left channel. That's pretty good. However, the right channel looks about 3/4 of a dB flatness, and the channel separation, the worst case separation between the two channels, looks like 0.9 dB. So the phono response is not the best I've seen, at least in the right channel. So here we have the THD SNR plot at 1 kilohertz for the phono stage to the tape monitor 1 output. The only spec given was a SNR of greater than 80 dB, and we're not there with either the left or right channel, the left channel being a bit closer at 73 dB, and the right channel is about 13 dB away from that. However, the THD looks good, and the THD plus noise is in the upper 60s, lower 70s. So overall, it's not horrid, but it's not the best that I've seen. So the previous THD SNR plot was taken at 2.5 millivolts. I should have pointed out, this one is taken at 5 millivolts, and it comes a lot closer to hitting the SNR requirement, at least for the left channel. And the THD looks pretty good, and the THD plus noise looks even better. I'm not sure why they spec'd it at 2.5 millivolts, but that's what they did back then. So this plot shows the effect of the loudness control, and remember there is a position 1 and a position 2. The spec is plus 3 dB at 100 Hz for position 1 and plus 6 dB at 100 Hz for position 2, and basically it looks like it's meeting the requirement. And here we have the THD SNR plot with the signal applied to the auxiliary input and the gain set for 29 dB and an output power of about 63 watts per channel into 8 ohms. And the SNR looks really good, about 98 dB. The THD is less than 0.007%. Now, the spec on this was a maximum THD of 0.02%, so we are definitely beating that. And the THD plus noise is in the 80s, so that's pretty good. So this old Kenwood KA-7100 is doing pretty good. So this is the THD SNR plot at 1 kilohertz with the signal applied to the auxiliary input. And the gain was set for 29 dB, and what I tried to do was get the max amount of power before the waveform started looking pretty ugly, and they kind of did right here at about 67 watts. So that's about the most you could get out of it, I think, before it turned really ugly. I mean, the THD isn't bad, but the THD plus noise is definitely getting bad, particularly on the left channel. And here's the frequency response at full power, i.e. 63 watts into 8 ohms. And there is very little difference between the frequency response when it was running at 5 watts and also 29 dB of gain. Our last piece of data is the multitone test results on the KA-7100. And what it's showing is about 8 bits of distortion-free range. A good amplifier would have at least 17 bits of distortion-free range. So this one's lacking in that department. However, this was not a test that was done on the KA-7100 back when it was released. The KA-7100 did meet its THD requirement at 60 watts into 8 ohms, both channels driven at 1 kilohertz. So that was pretty good. And as you saw earlier, it had some little data issues here and there, but overall it did really well. With all that being said, I hooked it up to my reference KEF speakers and listened to it for probably an hour and a half, and it sounded decent. It didn't, the 4 ohm load of the speakers didn't overtax it one little bit. I was able to hit 97 dB SPL levels, and according to my realistic APM 100 power meter, I was hitting peaks often between 50 and 70 watts into 4 ohm. I did a lot of listening at lower levels, and at about 10 watts I was getting 84 dB SPL. And like I said, the KA-7100 had no trouble driving the speakers, and it didn't get hot to the touch. It was up to maybe 130 degrees F at the very top of the case when I was done listening to it. So it's a nice clean sounding unit, and it was a pleasure just having it on my bench and looking at it. Once again, thank you for stopping by. If you haven't subscribed, please do so, and of course I would like to see any comments. And have a great day or night.